Hey everyone, in this video we'll learn how to transform a function and we'll learn all about shifts and reflections. So as you can see right here, we have a parabola drawn, f of x equals x squared in blue, and we are going to learn how to shift this function, f of x. So we're going to learn about vertical and horizontal shifts, starting with vertical shifts. So a vertical shift, let's define a new function, g of x, which is going to be the transformed function of f of x. So it's going to equal f of x, and we're going to add, so we are going to add 1 to it. So f of x plus 1. Now we can actually also figure out the formula for g of x. So g of x equals, what's f of x? Well, according to this, f of x equals x squared. So we could simply just substitute f of x for x squared, and then bring down the plus 1. So g of x is x squared plus 1. And x squared plus 1, it's simply f of x, which is x squared, but it's shifted up by 1. It's a vertical shift, and it's going to be shifted up by 1. So we're adding 1. So when you add 1, that shifts the graph up by 1. And then if you subtract a number, so if we were to subtract 1, which we can show in a little bit, it will shift the function down by 1. So let's take a look at how we're going to shift f of x up by 1. So how do we draw g of x? Well, let's start at the origin right here, 0, 0. Every point on f of x is just simply going to move up by 1. So 0, 0 will become 0, 1. 1, 1 will become 1, 2. Negative 1, 1 will be negative 1, 2. This will shift up by 1. This will shift up by 1. This will shift up by 1, and so will this. So as you can see, every point that was on f of x has been shifted up by 1, as you can see right here. And we're going to connect the points of this new parabola that we've plotted the points for. And we'll do the other side as well. Let me actually just do it from up here. Okay, there we go. So this new orange parabola that we have graphed, this is g of x. The orange one is g of x, which equals x squared plus 1. And then we have the original function f of x, which just equals x squared. So as you can see, g of x, the one in orange, it's just f of x, but it's shifted up by 1. We have done a vertical shift, so it's gone up the graph by 1. Now, let's draw another function. Let's call it h of x. And we are going to shift f of x down by 2. So h of x equals f of x. And how do we shift it down by 2? We're going to subtract 2. So it's going to be f of x minus 2. What this does right here, f of x minus 2, it's going to bring the function down by 2 spaces. So how do we write the formula for h of x? Let's go ahead and write that down together. That is, well, what is f of x? As we said, that's x squared. So h of x is x squared minus 2. Okay, so let's start at the blue function on our graph, f of x, the whole blue parabola. And we're going to shift every point down by 2. So starting with the origin, it's going to go down 2, so 1, 2. Over here, 1, 2. 1, 2. 1, 2. And same thing over here, 1, 2. 1, 2. And 1, 2. There we go. Let's connect all these points of this parabola. Then we'll go up here. And here as well. And there we go. This is h of x. the green parabola is h of x, which equals x squared minus 2. And that is how we perform vertical shifts on a function. So that's how we move a function up and down. Now let's talk about a different type of shift called horizontal shifts. So let's talk about horizontal shifts. And what that will do is it will move the function left and right. A horizontal shift. Horizontal. Let's go ahead and just get rid of all the other functions we've graphed on here except f of x, the blue one. We can go ahead and keep that. We'll get rid of that, h of x. Let's put that back. And what we're going to do is show how we can graph or how we can horizontally shift f of x equals x squared, which means we're going to move it left and right. So let's get rid of that. Okay. There we go. We'll get rid of that as well. Okay, so let's define a new function, g of x. And what we want g of x to do is we're going to shift f of x. We want to shift it 2 spaces to the right. So how do we write that down? Well, that is going to be f of x minus 2. So this is very different from the vertical shifts that we did. Remember, in the vertical shifts, so I'll write them quickly down here. We wanted to shift something down by 2. We simply just did f of x minus 2. This right here would make the function go down by 2. But right here, because the minus 2 is inside with the x, it's going to make it shift to the right by 2. It's within the function. It's going to be part of the input. Whereas the minus 2 was outside of the parentheses, so it's just the output minus 2. But over here, f of x minus 2, we're going to subtract 2 from the input, x minus 2. And this will shift it to 2 spaces to the right. So let's go ahead and first let's figure out the formula for this. What would g of x be? G of x. So we know f of x is x squared. So what's f of x minus 2? F of x minus 2 is x minus 2 squared. Because we're substituting x for x over here, that's how we input the values in our function. So if the input was x minus 2, our output is x minus 2 squared. And then you can tell this is a binomial squared. So you can use FOIL to expand it. If you decide to expand it, then this comes out to x squared minus 4x plus 4. So I'll go ahead and write that down, x squared minus 4x plus 4. Okay, so let's go ahead and draw this function. So g of x is simply just f of x shifted 2 spaces to the right. So we're going to shift every point here 2 spaces to the right. And let's go ahead and do that, starting with the origin. So 0, 0 becomes 2, 0. 1, 1 becomes 3, 1. Negative 1, 1 becomes 1, 1. This goes 2 spaces to the right. 1, 2. 1, 2. 1, 2. And 1, 2. There we go. Let me just get rid of this to make some space. And let's connect this parabola g of x in orange. So that side. And then that side. And there we go. This is g of x, which equals x squared minus 4x plus 4. And this is simply just f of x shifted 2 spaces to the right. Great, so now let's draw another function, h of x. So h of x which is going to shift f of x one space to the left. So how do we go one space to the left? So we want to go one space to the left, left by 1. We are going to do f of x plus 1. Plus 1. And very important to keep in mind, whenever you're doing horizontal shifts, within the input, so within the function, if you're doing x minus, so x minus 2, you're shifting to the right by 2. If you're doing x minus, you're shifting to the right. And if you're doing x plus, you're shifting to the left. Remember that for horizontal shift. If you're doing x minus, you're shifting to the right. If you're doing x plus, you're shifting to the left. So x plus 1, we're shifting to the left by 1. Good, so how do we, well, first let's figure out the function for h of x. So h of x, so we know f of x is x squared, so f of x plus 1 is x plus 1 squared. And then x plus 1 squared, if we go ahead and expand that binomial, that comes out to x squared plus 2x plus 1. Great. So let's go ahead and draw our function h of x. So h of x is just f of x, so this blue function, shifted to the left by 1. So we're going to shift this part to the left by 1. So we'll shift that to the left by 1. We'll shift this over here. This will go here, and this will go here. And then this piece will go here. That point will go there, and that point will go there. And there we go. Let's go ahead and connect the points of this parabola. And then we'll connect the other side as well. And there it is. That's h of x, which equals x squared plus 2x plus 1. And that's h of x in green. And all we did was shift f of x to the left by 1. So that is how horizontal shifts work. And that is how you shift a function. You can shift a function up, down, left, and right. And now we will talk about a different type of transformation called reflections. So I have this parabola drawn right here in blue, f of x equals x squared. And right here, we're going to talk about reflections. So I just realized I think I need a little more space. Let me go ahead and just expand the y-axis. So -4, -5, -6, -7, 8, -9. Perfect. So we're going to talk about reflections. So this function right here, f of x equals x squared, what we want to do is we are going to do a vertical reflection. A vertical reflection. So a vertical reflection, it will reflect f of x across the x-axis right here. So we have our x-axis right here. And what a vertical reflection will do is it will take the entire parabola and flip it upside down. So it will reflect the entire parabola across the x-axis. So how does a vertical reflection work? Well, let's go ahead and write down the function g of x. And that will equal, and we have f of x right here. So how do we reflect it across the x-axis? How do we flip it upside down? Well, what we're going to do is just put a negative in front of it. So putting that negative in front of it, it will go ahead and it will reflect it across the x-axis. So let's figure out that formula. So what is negative f of x? Well, we know f of x is x squared. So this is just negative x squared. So how do we graph g of x equals negative x squared? It is simply just this parabola in blue flipped upside down. So let's start at 0, 0. So 0, 0 stays in the same spot because it's flipping it across the x-axis. it's already on the x-axis. But now over here, 1, comma 1. To flip it, we just make the y-coordinate negative. So instead of 1, comma 1, it will become 1, comma negative 1. So 1, comma negative 1 goes here, and that reflects it across the x-axis. Good, and same thing over here, 2, comma 2. You just make the y-coordinate negative, so this becomes 2, comma negative 2. And then right here, 3, comma 9. Again, you make the y-coordinate negative, so this becomes 3, comma negative 9. Right here. And then same thing on the other side, negative 1, comma 1 becomes negative 1, comma negative 1. Negative 2, comma 2 becomes negative 2, comma negative 2. And then negative 3, comma 9, it becomes negative 3, comma negative 9. So all we're doing is just flipping the sign of the y-coordinates of these points. And then we have this upside down parabola right here. And there we go. So that's g of x. And g of x equals negative x squared. And what this is, it is just f of x reflected across the x-axis. So that is how we do a vertical reflection. Now let's talk about doing a horizontal reflection. So horizontal reflection, I'll write down right here. A horizontal reflection. So a horizontal reflection, instead of reflecting it across the x-axis, we're going to reflect it across the y-axis. So what I actually want to do, I don't want to use f of x equals x squared, because if we were to actually reflect f of x equals x squared, or any even function, by the way, if you do a horizontal reflection on any even function, it doesn't change. As you could see, if we have the y-axis right here, if we reflected f of x equals x squared across the y-axis, well, it would look exactly the same. It's just that this piece of the parabola would be reflected here, and then the other side of the parabola would go here. So it doesn't make any difference doing a horizontal reflection on this parabola f of x equals x squared. So what we're going to do instead is we're going to use a new function. So we're going to use a different function for f of x, and then we'll show how to do a horizontal reflection with it. So let's go ahead and just erase all this from the vertical reflection. And let's get rid of that as well. Okay, so for a horizontal reflection, let's go ahead and use a different function. Let's go ahead and use f of x equals the square root of x. So f of x is the square root of x. So how you draw that function, it would go 0, 0, 1, 1, 4, 2, and then, yeah, we can also go ahead and just extend the x-axis a little bit. So let's go ahead and do that, just so we can get 9, 3 as well. Okay, so right here, 8 and 9, and then 9, 3 would also be on this as well. We can go ahead and connect all these. And this is f of x equals radical x. Excellent. We have f of x equals radical x. And what we're going to do is we're going to perform a horizontal reflection on f of x. In a horizontal reflection, it reflects it across the y-axis. So we are going to take this, this f of x function, we're going to reflect it across the y-axis. So how do we do a horizontal reflection? Let's define a new function, g of x. It is simply going to be right here, f of negative x. So remember, for a vertical reflection, right here to reflect it across the y, or to reflect it across the x-axis, our g of x would have been negative f of x, so the negative would be outside. The negative would be outside the function, but over here the negative is part of the input for a horizontal reflection. So f of negative x. Okay, so what is f of negative x? What is the formula for that? So, well, we know that f of x is radical x. So f of negative x is radical negative x. Good, so radical negative x. Now, how do we graph this? How do we reflect f of x right here in blue across the y-axis? All we have to do is we're going to take each point and just switch the sign of the x-coordinate now. So 0, 0 stays 0, 0. 1, 1, so 1, 1, it flips to negative 1, 1. So we're flipping the x-coordinate now. In a horizontal reflection, we flip the sign of the x-coordinate, and in the vertical reflection, we flip the sign of the y-coordinate. So we're going to be flipping the sign of the x-coordinate. So 1, 1 becomes negative 1, 1. 4, 2 becomes negative 4, 2. And 9, 3 becomes negative 9, 3. Let me actually go ahead and just expand this. So we have negative 9, negative 8, negative 9. So it becomes negative 9, 3. And there we go. We can go ahead and connect the points of this graph. And we have g of x, which equals negative radical x. And there it is. G of x, it is just f of x flipped across the y-axis. And there we go. That's how we perform a horizontal reflection on a function. So those are how you do shifts and reflections to a function. I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.